Instructions for projects featured in this series, presented by Sue Hausman and her guests, is available.
Are issued based on these radar returns. 80% of the time, they are false alarms, because 80% of the times the funnel clouds do not touch down. So we need a active...
Home, not elsewhere. But you can actually, you men out there, can grab your testicle and give it a nice sharp squeeze. And when you do that, you'll feel that the pain is way up here in the abdomen and not necessarily down in the groin. It is because of this embryology that that pain is so deep and so severe. Great question. Thanks for throwing it our way.
Most people wouldn't even want to touch it, but a very lucky crew kept their wits about them on a recent excursion, and for that, a lot of scientists are grateful.
The Ocean Selector is just back from the fishing grounds off Vancouver Island, unloading its usual catch of groundfish. But just before Christmas, this same boat netted something completely unexpected. Perhaps one of the biggest scientific catches in years.
This is the Hewlett and Barkley Sound right here, and I was in a place called Barkley Canyon. And we were right about where this 584 is right here.
They were working in about 1,000 meters of water, about 100 kilometers off Vancouver Island, a place where they'd often filled their nets before. On the last haul of the day, they dragged their nets across the seafloor and pulled up more than they had ever bargained for. Brian Dickens was the captain that day.
The whole net floated up, and it stuck right up out of the water, and you could just see the water frothing everywhere, and I was like, oh!
And, we thought maybe we'd perhaps got an old gas cylinder.
Chris Cleary was also on the boat.
It exploded out of the water in a ball of bubbles and gas and sat on top of the water and it's sort of like a giant aspirin tablet.
Cleary grabbed a camera and snapped these pictures.
It looked like ice.
No one on the boat had ever seen anything like it before. They'd hauled up at least 1,000 kilograms of what they thought was ice. But this was no ordinary ice. It hissed, it bubbled, it fizzled on the boat deck.
It had a fairly pungent, a pungent smell. Yeah, and I collected a small piece of it and put it in a plastic bag, and of course it kept reacting and giving off a lot of gas and blowing the bag open.
What was left in the plastic bag was sent to the Institute for Ocean Sciences in Victoria.
A little bit of crud on it.
The residue on the plastic was methane, a highly flammable gas. What they hauled aboard was methane hydrate, natural gas locked in ice crystals.
Solid material.
The methane reserves come from the decomposition of ancient animal and plant matter. Compressed at high pressure and low temperature, methane hydrate forms. The extreme pressure under the ocean keeps the gas a solid, but when the pressure is reduced as it's brought to the surface, the methane turns to gas.
Touch it with a flame.
Put a match to it and it burns. The crew was lucky they didn't blow up the boat.
It's really cold.
Geologists have known about methane hydrate for years. In fact, a team of oceanographers spent most of last summer looking for it in an area just 50 kilometers from where the boat accidentally snagged its catch.
The only hydrate that we knew about here was from our seismic investigations that showed hydrate at about 200 meters below the seafloor. So to actually have somebody find or prove to us that there's hydrate right on the seafloor was a serendipitous discovery that was really remarkable.
In all their research, the team from the Institute of Ocean Sciences had only managed to recover a tiny sliver of methane hydrate, and they had to drill into the seafloor to find it. That in itself was an exciting find, but it paled by comparison to what the crew of the Ocean Selector found.
Certainly when we heard of and saw the pictures of Chris's, of the recovery from the fishing boat, of a ton of the material, it sort of put things a bit in perspective as to what can be obtained, and extremely fortuitous, extremely lucky that they were able to get that in a very unusual sort of circumstance.
The scientists believe the Ocean Selector's net accidentally broke off an outcrop of rock and icy methane, probably about 2 tons of it. They guess at least half of it fizzled away as pressure changed during the ascent.
Gas hydrates are tremendously efficient at storing gas.
Scientists are interested in the icy gas because it could prove to be a rich new energy source. As a solid, it could be hauled up in large chunks. It's estimated that there is enough methane hydrate locked away off Canada's west coast to meet North America's energy needs for at least 30 years. Until now, it was thought most of the hydrate would be difficult to reach because it was buried in a layer under the seafloor. The Ocean Selector's discovery means at least some of the material is sitting right in the open and easy to get to. Geologists are already wondering if the methane hydrate could be mined. But the promise of methane hydrate also harbors danger. The deposits are right on the edge of the Juan de Fuca plate.
This area.
The same spot that seismologists expect will produce a massive earthquake in the next few hundred years.
There is gas probably below the solid material. So it becomes solid, or it remains solid down to, in our area, about 200 meters below the seafloor. And below that, there's probably reasonable quantities of the free gas.
The methane starts out as a gas deep in the Earth's crust, where it's warm. As it seeps up, it reaches the cooler seafloor, and the gas turns to a solid. And scientists worry that if the seafloor and the solid layer of methane hydrate rips open during an earthquake, huge bubbles of methane will be released from deep in the Earth's crust.
If there was a large release of methane from the hydrate system, what effect would that have on local climate or even global climate if there was enough of it? I don't know, but you have to worry about that other side of the coin.
Methane is a greenhouse gas. Geological evidence shows that past periods of climate warming coincide with huge inputs of hydrocarbons. Scientists speculate those hydrocarbons were released from under the ocean floor in the form of methane gas. Back at sea, scientists say the chances of another trawler finding more methane hydrate are highly unlikely. There have been no calls to shut down the fishing grounds, even though this is the largest amount ever brought to the surface at once.
But we'll follow up, try to get what sort of location information there is.
Scientists will return to the site this summer. They'll use records from the global positioning system aboard the Ocean Selector, and they'll take a deep-sea camera to see how much hydrate the fishing boat missed. For scientists and the crew of the Ocean Selector, it's a fish story they won't soon forget.
When we come back, counting snow, mathematician Fraser Simpson challenges you to calculate accumulation using only your math skills. We've seen our fair share of snow this year, and it does come in handy for things like snowmen and snowballs, but it also makes for a great math puzzle. Our resident mathematician took advantage of the season, and this week he's back with the answer to a very flaky puzzle.
Last week, we had a problem about snow, and here's how it went. On February 1st at noon, it begins to snow onto bare ground. And then the weather starts to follow a strange alternating pattern of snowing for 6 hours, then not snowing for 18 hours, then snowing for 6 hours, then not snowing for 18 hours, and so on. Now, during every 6-hour stint of continuous snowfall, 6 centimeters of fallen snow collects. And during every 18-hour stint of no snow, 4 centimeters of the fallen snow melts. Now, if this weird weather pattern continues throughout the month, on which date in February does the total accumulation of snow first reach 36 centimeters? You might think that you could solve the puzzle this way. We have a net gain of 2 centimeters each day. So on February 2nd, we have 2 centimeters on the ground. On February 3rd, we have 4 centimeters, and so on. Since we want a total accumulation of 36 centimeters, we simply divide 36 centimeters by 2 to find that this would happen 18 days after February 1st, which means that February 19th would be the solution. But that's not the correct answer. You see, the problem asked for the first time the total accumulation reaches 36 centimeters. And since we have a seesaw pattern of up 6, down 4, up 6, down 4, the first time we have 36 centimeters is at 6 p.m. on the same day that we had 30 centimeters collected at noon. So when do we have 30 centimeters on the ground at noon? Well, at 2 centimeter net gain a day, that would be 15 days after February 1st, or February 16th. On that day, it snows from noon until 6 p.m., giving us 6 more centimeters of snow and giving us a total accumulation of 36 centimeters of snow for the first time. So the correct answer is February the 16th. Coming up, the winners in our random draw amongst those who sent in correct solutions. Tune in next month for a new problem on the numbers game. I'm Fraser Simpson. See you then.
On the scene, behind the scenes.